Hey kids, Mr. Murray here, Mr. Murray's Mathland, and we are talking about inverse trig today, and just very basic stuff with it. Specifically, how to evaluate basic unit circle kinds of values from it. So a little bit first about the notation. You should know this. This is the calculator notation that you've been using for a few years, but just to reiterate, that is not sine to the -1. It's not a -1 exponent. It's got nothing to do with reciprocals. It's the inverse sine function, And this, which you may or may not have seen prior to this point, arcsine, that means the same thing as this. So these two things both mean inverse sine, and I think arcsine may be preferable because that way it's kind of clear. There's no -1 exponent. It couldn't possibly be interpreted that way. So I kind of like that notation, but you got to be comfortable with both. And it's really just from context. So these are pretty simple once you get the hang of it, but a little background on why these rules work. Because what you're looking for here, inverse functions generally, right? They're x and y are switched. So you're talking about inverse sine of 1/2. You're saying what angle has a sine of 1/2. And you might be thinking, well, that's pi over 6 in quadrant 1. That's 5 pi over 6 in quadrant 2, where sine is also positive. And also plus or minus 2 pi, however many times I want, on and so forth into infinity and negative infinity. There's an infinite amount of angles. And that is true. So to make these inverse functions, we have to have only one answer to it. One and only one, right? That's the definition of a function. For any input, there must be only one output that everybody has to agree on. So we restrict the range for these to a very specific window. And here's just the thought process, which might tie into some old characteristics of yours. Here is the sine graph, super rough sketch, right? There's one period of sine to 2 pi. There's did not draw it very well. It's not very symmetric, but deal with it. 0 to 2 pi, and of course, and it keeps going, and it keeps going in the negative direction as well. So you may recall that a function passes the vertical line test, but if it doesn't pass the horizontal line test, then it's not a one-to-one function, meaning its inverse is not a function. And that's basically talking about, where does sine equal 1/2? That's at pi over 6 right here, but also 5 pi over 6 has a y value of 1/2. And so there's the two places. That fails the vertical or the horizontal line test. So we restrict the range, and so we select this portion of the curve from -pi over 2 to pi over 2, because if you look at that, just that one little strip of the graph really contains all of the y values that this curve ever has. And it goes from -1 to +1, hits everything in between, and then after that it just repeats those y values. So if you focus on just this strip, this does pass the horizontal line test, which makes this 1-to-1. So we restrict our range for arcsine, inverse sine, to -pi over 2 to pi over 2. That means any answer you give must be in that window to an arcsine or inverse sine question. And it's kind of like thinking like this, to tie it into your unit circle, right? You got all students take calculus, places where things are positive, but since we're going to restrict that, we're basically going to say we're going to use quadrant 1, which is 0 to pi over 2, for any of the positive values. So that'll cover with no repeats. But we're also going to use 0 to -pi over 2, quadrant 4, for any of the negatives. And there we go, one quadrant for the positives, one quadrant for the negatives. That's what this is really showing. So finally, after all that explanation there, the inverse sine of 1/2, what angle has a sine of 1/2 and is in this window? And that is only pi over 6, right? That's right here, right? That's the only point that's on this little red strip of the graph. Pi over 6, only one output. And for arcsine of negative 1/2, when does this have a value of negative 1/2? If you're thinking of your quadrants, okay, well, we're talking about quadrant 4, that's where sine is negative, but don't give 11 pi over 6, that's going the long way around, that's going past pi over 2. You want to go the short way, which is just go in the negative direction. So go negative pi over 6. There you go, and that's really, if you want to tie back to this, you're talking about this point on the graph. When y is negative 1/2, that's negative pi over 6. So really, you know, that sometimes throws kids off a little bit, but not too big a deal once you get the hang of it. You just take the reference angle and make it negative. That's actually kind of easier that way. So yeah, if you were to test this on your calculator and change it to degree mode, if you do inverse sine of negative 1/2, it'll give you negative 30 degrees, or negative pi over 6. And that's it. Okay, let's try a couple with arctan and arc cosine, just to see a couple more examples, but that's really the idea. Now arctan, also, all these have restricted ranges because all those trig functions are cyclical. So just a little explanation of why each one is which maybe makes it stick with you a little bit better, so it's not just memorizing some arbitrary windows here. But that's the tangent graph, your normal tangent graph, right? And it repeats over and over again. And that period of pi begins at negative pi over 2 and ends at pi over 2. And so that kind of, that one cycle of it really captures it all pretty well. So we really stick with that same restricted range for arctan that we do for arcsine, from negative pi over 2 to pi over 2. So any output, any answer you give to an inverse tangent question is going to stick with that same window. So quadrant 1, 0 to pi over 2 for any of the positives, and quadrant 4, 0 to negative pi over 2 for the negatives, going the short way, going in the negative direction. So arctan of 1, what angle has a tangent of 1? You gotta draw your triangles, your chart, your circle, whatever, but that would be pi over 4, right? That is the one time when y and x are the same and the ratio is 1. Inverse tangent of negative 1, same thing as arctan of negative 1. What angle has a tangent of negative 1 and is in this window? That would be pi over 4, but negative. So negative pi over 4, right? And here's the 2 points you're kind of talking about here. There's pi over 4 with a y value of 1. Here's negative pi over 4 with a y value of negative 1, right? Quadrant 1 for the positive, quadrant 4 short way for the negatives. Good. All right, last one here. Let's do a cosine. So maybe you're feeling like, hey, this is cool, I got the hang of this. But arc cosine, if you think about what its restricted range would be, it's not the same as arctan and arcsine. And because cosine looks like that, right? Starts at the crest at 0, and if you continue in the negative direction to negative pi over 2, again, this is more effective if you do it to scale, but you get the gist there. If you go negative pi over 2 to pi over 2, that portion will not satisfy the horizontal line test. Or, to use your quadrants, 0 to pi will, for the 0 to pi over 2 for the positives, but if you go in the negative direction, that's quadrant 4 where cosine is also positive. So not going to use that chunk, not going to use quadrant 4, just going to keep going through quadrant 2. So from 0 to pi, because in quadrant 2, cosine is negative. So use quadrant 2 for the negatives, quadrant 1 for the positives. Or on the sinusoidal graph here, that's just going 0 to pi. 0 to pi, there's that one little strip of the curve that will cover all your y values. So here we go. That's the one thing to watch out for. But if you think about it, it's really not too big a deal. So arc cosine of root 2 over 2, what angle has a cosine of root 2 over 2 and is in this window? That is pi over 4. So any of these that are, positive ratios, that's pretty easy. Most people don't mess that up. It's just quadrant 1, pi over 4, pi over 6, pi over 3, whatever it may be. The negatives are sometimes where people mishandle, and so you got to think about that range. So where is cosine negative root 2 over 2 and in this window? So that's just another pi over 4, but quadrant 2, 3 pi over 4, right? And on the sinusoidal graph, here's pi over 4 when the y value is root 2 over 2, and 3 pi over 4 just before pi when it's negative. And there you go. So that's that. Hope you enjoy. Hope it makes more sense and not just memorizing random rules. But if you have questions, let me know. Take it easy. Keep working hard.